All right, students. So on the last video, I kind of forgot to get to the quiz section where I was going to go over some quiz questions. So I'm going to do that on this video. So I'm just going to hop right back into our week 8 module. Let me go to CK12. I'm going to go over about 3 or 4 of these and sort of give you the reasoning behind the answers. But this way, just by watching these videos, you'll get a little extra content, a little extra knowledge, and a little help on the quiz. So if I hop right into it, so our Igneous Rocks quiz. So this one, the olivine crystals forming at a much higher temperature than quartz. So that one you want to look back to your Bowman's reaction series. So what I'm going to do is I'm going to hop in back to our CK12 unit, and I'm going to show you right where you can find this. Just in case you ever get lost in it, you want to look it up, or you want confirmation. Maybe you think I'm a liar. That's fine. You have every right to think that. You don't know me that well. You only know me through the computer. Who knows? Anyway, no, I'm not a liar. I'm straight up with all this. And so if we go back down to the Bowman's reaction series here, you'll see what I'm talking about. So olivine, yeah, it is crystallizing out a little bit higher than quartz. And so let's see if that's true. Yay, we get another one and we get to move along. And so the next one's saying that in the Earth's crust, temperature decreases with depth. Part of the problem with some of these questions is we'll try to mix you up with the wording. So if they're saying that the temperature decreases with depth, they're saying it gets colder as you go through the layers of the Earth. If we look back at our, PowerPoint, the PDF that we have, we looked here at the gradient. And let me see if I can pull up the right one. Maybe I went too far. I think I went too far. Let me hop back. I was just looking for the geothermal gradient. Oh, there we went. I went right by it. So it says the rate at which the temperature increases with depth. So you can see even from this graphic, as we go down into the Earth, the temperature increases. So if I go back to CK12, does the temperature decrease with depth? Does it get colder as I go down? Nope. It gets hotter. So I'm going to say false. I'm going to say check it. It's going to give me the right answer. And so that's why I say it's always beneficial to have these up at the same time, to always go back and forth. And then it says the same parent rock can produce magmas of different composition if the melting temperature is different. Well, we know from what we saw in the Bowman's reaction series is that minerals will melt and crystallize at different temperatures. So if a certain mineral crystallizes out and it takes with it certain chemical constituents, it makes sense that it can produce a different magma of different composition if the melting temperature is different, because we can have different things that will crystallize out at different temperatures. So I'm going to try true. I didn't even look at my PDF to confirm it. There we go. We're correct. All right. And we can see where some of the things start to make sense. So now, number 4 says that the increased pressure raises the melting temperature of a rock. So if we go back into here with pressure, so this is right around here as well, the decompression melting. So it can occur when hot mantle rock moves upward and the pressure is reduced. And then also the melting point of minerals increases with increasing pressure. So increasing pressure increases the melting temperature of the rock? Absolutely, because with more pressure, it won't melt as quickly, and we need to raise the temperature in order to do that. So let's see if we're right. Yay, already 4 out of 19 correct. We are cruising towards perfection. All minerals melt at the same temperature. This should be a pretty straightforward one, because if we look at that Bowman's reaction series, I'm sorry, let me hop back, not to get too far away from it. We say that minerals crystallize in sequence with decreasing temperature. So there's a sequence to which they crystallize out. Therefore, they do not melt at the same temperature. Bingo! Keep moving on. So extrusive igneous rocks form from magma that cools and solidifies within the Earth's crust. So let's think about it. Extrusive rocks are volcanic rocks. Vulcan was the god of fire. These need to be erupted. Extrusive means exterior, outside of the Earth, while intrusive means within. So if intrusive means within, Extrusive means without. Extrusive rocks cannot form within the earth. So this would be categorically false. We are doing well. Last one we'll go over, because then you'll start to get the flow of it, how you can hop back and forth. So the Sierra Nevada mountains are made from, now this one, this is a good one for us to go over. I'm not too certain. I think I touched on it in the lecture, but they do touch on it in the CK12 work. So this is where the CK12 work helps to bolster up the lecture. Now, we will have a whole lecture dedicated to the Sierra Nevadas, but in this case, you want to work on this based off of what you read in the CK12 stuff. So they're made from mafic, felsic. So mafic is iron rich. We want to think basalt seafloor. The Sierra Nevadas definitely aren't the seafloor. They're, big giant mountains on the continents. Therefore, they are more felsic, which means they have more silica. So we've sort of eliminated it down to just either be B or C based off of the felsic. But with the Sierra Nevadas, they were gigantic plutons. So these were huge, enormous, incomprehensible in size bodies of magma that were plutons that rose through the crust. So since they were plutons that cooled, Pluto is the god of the underworld. They were formed within the earth, so that would be an intrusive rock. Let's see if we're right. Holy moly, look at this. We're doing great. So there you go. You can get that connection between going back and forth between what you've learned on CK12, what you've seen in the PowerPoint, and maybe what you heard in the lecture. So use all those resources, and there you have 7 answers already done for you. So I hope you enjoyed that.